Welcome back, everyone. We are kicking off where we left off last time. And for those that don't know me, I'm just starting to stream around this stuff, and I'm learning both Rust, the programming language. It's something I've been learning on and off for a while, but I'm sort of de-rusting, hopefully, some of the knowledge that I gained a few years ago and picking it up again. And I'm learning the graphics library WebGPU as well, which is pretty cool. And so the Rust library is WGPU. I was given a steer in a previous video to look at this tutorial, Learn WGPU, which I'm doing, which is really good. And we're getting through it. So what we're up to today is we've just finished instancing, actually. And so what we're doing now is we're looking at the depth buffer. So if I sort of just maybe reset and have a look at what we've got here. So cargo run. This is our little demo environment based off the tutorial that we're building. We've been drawing this polygon for a while, and we can change the texture, and now we've just used instancing to draw 100 of these things, like 10 by 10. And so far so good. That seems to be working quite well. But apparently there were some issues with the way that the drawing order was implemented. And so the idea here is that we're going to look at a depth buffer. Now in the stream today, what I'm going to try and do is get through at least the depth buffer and probably model loading as well. It might be a longer stream. I'm going to try and do more of these once a week, like I said a while ago. Finally, I think I finally have my hardware configuration set up here. And I've got, I think I've got everything going in terms of audio and the right setup here and reliable setup. So previous issues with capture cards are sorted out. And so if I stream once a week, I'll probably be working on this stuff in between anyway. But once a week is, it's a schedule. People can jump on board if they want to and follow along. We're already quite a way into the tutorial. I have been putting this stuff on my GitHub repo, which is here, GitHub Snarky Boojum. And then if you look at, I've got a repository called Simul, and then inside of here, WGPU dev, and this is kind of where we're committing all the code so far, which seems to be working pretty well. And so you should see me do commits in here, hopefully several times a week if I'm able to get stuff done with my other workload. Anyway, and so we're going to go and step into depth buffer and see how far we get. Our code is here. Now a lot of this stuff looks copy and pasted from the tutorial. I mean, there's 770 lines of code now, just in the librs, and then we've got some texture stuff moved off into texture. And there's a shader as well, which is still pretty simple. And these are my two textures. One is a PNG, one is a JPEG. This is the one they use in the tutorial, and I downloaded the Plan 9 Space Bunny Glenda, which is my favorite. I use that icon probably without copyright. Oops. Anyway, I use that for my avatar in a bunch of places. So that's the deal. And I was mucking around, looking at model loading, and I found a couple of free models. Who knows if this is possible? I don't know. I've never loaded a model in my life using any graphics library, let alone WebGPU. I think I might have looked at it years ago with OpenGL, but I think I was helping a friend or something. But no, really, I have no knowledge of this stuff at all. And so we're up to depth buffer. So for those that want to follow along, please do. I'm a newbie when it comes to Rust. Pretty much. I'm certainly very much a newbie when it comes to graphics in general. And so anyway, go easy on me. And for those that comment, thank you. There's been a couple of really good comments, very constructive comments about recommendations for reading. Someone recommended that I look at, it was one of these, WebGPU Fundamentals. I should shout out that guy. Anyway, it'll be obvious in the comments, but he's been particularly supportive, so thank you to that person. I'll go through that next. But anyway, we're gonna slam into this. So depth buffer. So I guess the depth buffer is an approach to solving where you have draw order, where you want to be able to draw things accurately, and you want to have objects behind objects that are in front occluded appropriately, and you don't want, the pixels representing those objects to be drawn over the ones that are in front of them, and so on. And so this tutorial goes through a couple of ideas: sorting your objects from back to front. And I guess you draw from the back first, and then you progressively draw to the front. And that works, but is kind of slow with lots and lots of objects. And so they introduce something called a depth buffer. Now, this depth buffer, the one that they're talking about here, is they use a texture. And I presume, I don't know this for sure yet, but I think what they'll be doing, and it's worth guessing anyway, just to see how wrong we are. But I guess depends on how many layers, or maybe it's distance from the camera. Let's say distance from camera. And so maybe you have a texture that represents, for each pixel that you need to render, which sounds pretty hardcore, doesn't it, in terms of performance? But anyway, you have a pixel that takes a value that represents the distance from the camera. And you don't care about whether it's RGB. You're never really interpreting it, I don't think, as something you would look at. But it would be fun to look at it maybe as a RGB image, or a grayscale image, or something along those lines, just to see what the depth buffer thinks is going on. And so, I don't know, maybe what would work? I mean, who knows? If it's close, it should be lighter. If it's further away, it should be darker. I don't know doesn't really matter. But it'd be fun to see what that looks like. So maybe that's an extension. And in fact, since the depth is texture, we can sample it. And because it's a depth texture, so there is a challenge to render the depth buffer to the screen, or the depth texture rather. Now, I've done a bit of reading, and apparently a depth texture works well, but for high performance situations, there are more performant buffers that can be used, not textures. And I don't really know why or how that would work. But I guess we'll get to it. Now, when I'm coding, I typically code in increments of 30 minutes, and so let's try and do that. And I'll probably take breaks every 30 minutes. Might do a longer stream today. So let's get started. Z ordering. Oh yeah, and the axes here are X horizontally, Y vertically, and Z in and out of the plane or the screen, I believe. And so Z order is the depth of these objects virtually, I suppose, in the world. In 3D rendering, it gets trickier because the order can change based on camera angle. Yep, makes sense. Like if you do a 180, then everything gets reversed. A simple way of doing this is to sort all objects by their distance from the camera's position. There are flaws. When a large object is behind a small object, parts of the large object should be in front. Okay, yeah. So I guess if there are objects that are like leaning over the front of another object, even though the object might be technically stacked behind, parts of it could be in front of other objects, and then objects that overlap themselves. Yeah, sure. Why not? If we want to do this properly, we need to have pixel level precision. And at 4K or at high res, that's lots of pixels. Where there's a depth buffer. Okay. The depth buffer is black and white texture that stores Z coordinate rendered pixels. WGB can use this when drawing new pixels to determine whether or not to replace or keep data. This is depth testing. Okay. This will fix our draw order problem without us needing to sort our objects. Let's make a function. Okay. Now, yeah. Okay. So we want to create a function. And there'll be a depth format. So we'll do depth format, which is the type of texture. Texture format. And that will be depth 32 float. 32 bits of precision. So 2 bits for depth. So 2 to the 32. Well, It's not really, is it? Because it's signed, I guess. Or is it unsigned? Let's find out. I'm always curious about these things. So we want to look at depth 32 float. Okay. Depth 32 float. 32-bit floating point depth. In WGPU is signed or unsigned? Unsigned. Yeah, cool. So 2 to the power of 32. Nice. Presumably could have found that out myself, but anyway. Okay. All right. Okay. So then what you do is you'll create a texture the size of the surface, width and height. So that's what this is doing. So we need access to our surface configuration. Then you create a descriptor. D2 I think was 2-dimensional textures. .2D texture. Okay. Format is that. Usage is render attachment, so to render it, I guess. Rendering 2, okay. And then texture binding. No view formats. And then we create the texture, then we create a view. Then we create a sampler. Okay, so we don't need a sampler because we're never rendering it, but later on we might. So, and this just tells us what to do when we go off the edges, or sorry, when we, well, let's remind ourselves, sample descriptor. How to deal with if it's in the Y, Z, sorry, X, Y, Z, okay. Compare. What does compare do? If this is enabled, this is a comparison sampler using the given comparison function. Comparison sampler, sure. LOD. Don't remember all these from last time. So 0 to 100, okay. And then it returns the texture. All right, so this sets up the texture format, but doesn't put anything in the texture. Create depth texture. A label. spool. Hilarious. All right. All right. So, so it needs to be an extent 3D. Height config.height. This is really annoying, isn't it? And then depth of array layers is 1, I presume. Cool. So we've got our size now. Then we need a descriptor before create the texture. But this is created via a device. Label size map. Yeah, goodness. Label is, what are we calling it? Given label. Of course we have. Size is already defined there. Calculated. MIP level is sample is 1. What does sample do? Sample count of texture. For multi-sampling. All right, we're not doing that. Dimension will be D2. Format will be self depth format. Usage will be texture usages render. And render and binding. Okay. A reference to that. So we've got our texture. Then we need a view. Create view. Texture view descriptor. Apparently we can just use the default. Helpful. Then the sampler is code from the device as well. So many fields required here. I know it seems a bit stupid to just do everything manually like this, but V, W, mag filter, linear, min, min map filter, nearest, oh, it's helpful, compare, less than or equal to. Level of detail min clamp is 0, and then the max level of detail max clamp is and then default. Whoop. Oh my god. Okay. What's this complaining about? Minimap filter. What's it called? MIP map. Oh my god. All right. I'm a noob. All right. So we've got hopefully something that will work. Give us a sampler. Or not. Okay. So we've got texture view and sampler. Good. That's done. I've already spent 14 minutes on this, or 15 minutes. Okay, so let's have a look. We need the depth format for creating the depth stage. The depth texture needs to be the same size. We're rendering it, so we need render attachment. We don't need a sampler. We do decide, if we do decide we'll to render our depth texture, we'll need compare less equals. This is due to how sampler comparison. Okay, cool. If you say so. I don't know what that means. We create our depth texture in state new. And then we add it to the render pipeline. Oh, is this broken now? Somehow it's not working. We certainly don't need that. All right. So we'll need inside of function new. When do we create our depth texture? That is the question. I guess like after we create instances, maybe? I don't know. Create our depth texture. So let's do let depth texture equal texture create depth texture. Device config, and then the label will be depth texture, I guess. Is that right? Yep, that looks good. All right. So we've got our depth texture now. And then we need to add that to the render pipeline. And does that mean, like, where does it go? Depth stencil. Is it a reference here? Depth texture? Some. Nope. Ha! Depth stencil state. All right. Some depth stencil state. And then inside of that, we'll need a format. Goodness me. All right, so this just allows depth testing. It doesn't actually set anything up. It doesn't use our texture yet. All right, so we need format. We've already got it, haven't we? Depth format. Depth write enabled. Do we need write enabled? I guess we do. True. Then we need depth compare. Less, yeah. We need stencil state. Who knows what stencil state is? Is it another thing here? Or like, what is it? Front, back, read, mask. No idea. Can I just use defaults? And then bias, depth bias state. Again, what's this? Constant slope scale. I guess we can use defaults, so I'm just guessing. Okay, so this somehow tells the render pipeline that it can do depth testing, should do depth testing, can do it, but it doesn't actually do anything. Depth compare function tells us when to discard a new pixel. Using less means pixel will be drawn front to back. Okay. Yeah. I don't really care about any of this. So front to back would be, so back to front would be greater. What does equals mean? Compare function. Part of me wants to get into the detail of this, so I guess it'll just take time. Not in this tutorial. There's another type of buffer called a stencil buffer. Sure, it's common practice to store the stencil buffer and depth buffer in the same texture. So that means they don't overlap, I guess. These fields control values for stencil testing. I don't even know what stencil testing is. What is stencil testing? What is stencil testing? I think it's something to do with shadows. To control the drawing of pixels based on a stencil buffer. It's an additional buffer similar to depth that holds an integer value for each pixel. Control whether it should be drawn or discarded. Enables various advanced rendering techniques such as shadow volumes, if you say so, outlining objects, and complex masking. Cool. Stencil. I guess stenciling, right? Just like where you, as a kid, used to create a stencil and then use that to draw things in. I don't know. All right. I remember Carmack talking about it in Quake 3. Quake 3 days, I believe, where he was using stencil buffers for shadows, real-time shadows or something. Did Quake 3 use stencil buffers? Rendering. Did not. Glad I checked myself. Fact check. Oh wow. Light maps and shaders. Cool. Alright, there you go. So Carmack was ahead of his time as usual. Cool. Don't forget to store the depth texture in state. Yes, sir. So depth texture. Is that what I called it? Yep. So if we go to the end of this thing, This is render. Should be a no, it's a texture. All right, depth texture is there. Never read. If you say so. Surely it is. Blend texture is red. Isn't it? Yes. Okay. Do we still run? Let's test. Do we build? No. Do we run? Nope. Oh yeah, cool. So now, this is good. So error-driven development. Render pipeline targets are incompatible with render pass. Okay, so let's find our render pass. Render pass. So we need to now set a, what do we do? Do we set, like how does that work? Oh, resize, render pass. Okay, so we need a depth stencil attachment, which is a render pass depth stencil, blah, blah, blah. Some WGPU, that thing. And what does it need? It needs a texture view. Self, no. Self, oh my God, what am I doing? It needs a view, which is self dot depth texture view. Then it needs a depth ops. I have no idea what that is. Okay, so Rust has done something differently. So we need a load. I mean, what is this even doing? Depth ops. Load does it clear, and store does it store? Yeah. Okay. Let's look up what that actually means, because I don't like that. Clear with one, was it? Yep. And then it needed a store, and that was a store up. What are the options? Then we needed a stencil ops. Okay. Okay, so this should build and run. Let's try run. But it won't work on resize. Yeah, great. Okay, the depth attachment texture view has extent that, but it's followed by the color thing that was bigger. It took 2 pixels to notice. Okay, so let's find our resize majiggery. Yeah, resize. And so what do? We have to resize the surface, but we also need to resize the buffer, the texture. How does that work? Can you just do like self? So I'm going to cheat, resize, create it. You have to recreate it. So it says you have to update depth texture after you update config. Well, does that mean the field, or does that mean configuring the surface? I guess we'll find out. Self dot depth texture equals it's a new texture. So we have to create a new texture. Seems inefficient, doesn't it? Can't you just like scale the existing one? Okay, all right. So self.device config. Did it? Oh, that's so nice. And then what do we call it? Depth texture. Sure. Oh. What? Depth texture. Let's see what order this needs to be done in. Okay, so renders, happy days. It doesn't crash now. Okay. But we didn't create the texture anyway. Where did we actually create the texture? That's what I don't get. Does it automatically get created for us or something? Like, we're not writing to the texture. We're rendering to it. Oh man. Okay. Come on, GPT, you can tell me. When I create a thing, how does the texture get written to? Bind it to the render pass. But how does it actually get written to? Like, does the render pass just magically? I don't get it. Maybe that's what these operations are. The bit we didn't understand. All right, now we're gonna understand this thing. All right, so let's go and read the documentation. We're gonna try and understand it anyway. So this thing describes the attachment. Yeah, right. So let's. Depth ops. But what does the writing to the texture? Is it in the render pass depth? Oh my god! Depth stencil attachment with the WGPU operations, or is it somewhere else? Man, I should use voice. During the render pass, when the GPU executes the rendering commands, the writing is controlled by the configuration in the render blah blah in this thing. And the depth and stencil operations specified in the operations. Yeah, right. Here's a closer look. Okay. Clears the depth buffer to 0 to 1 at the start of the pass. Ensures the depth buffer is written back to the texture after the pass. We don't use load. Oh yeah, we do. Okay, so it gets cleared. What does a value of 1.0 represent in the load? Oh, then. Furthest possible value. Oh, it's a normalized value. Ah, so these values are normalized then. Oh, come on ChatGPT. Sure. Just for fun, let's make it 0 and see what happens. Does it like get the overlapping wrong or something stupid? All right. Totally screws everything up. Doesn't render anything. Fascinating. Less. Greater. When in doubt, just randomly change stuff and see what happens. Oh. I mean, it was specified as less in here as well. Sampler, but we don't use the sampler. Yeah. Fascinating. Got a bit of a better understanding, but anyway, not 100%. All right, great. So no shader code needed. Great. All right, so I would like to see what this depth buffer thing looks like. And I think that's the next challenge. Sample in the shader. Sampler comparison uniform type and the texture sample compare function. Gives us a bit of a hint. All right, I'm going to take a break. I'm going to come back and have a crack at this challenge, and then we'll get on to model loading. See if we can load a custom model. All right. Thanks, folks. Back in a bit. All right, we're back. Been looking at this in a little bit more depth. It's going to be a huge amount of work, so I'm gonna park it here. Actually, it's been an hour, um, and then I'm gonna look into this. I'll probably do a bit more research. I've got quite a bit of gap in my knowledge, but I mean, basically, what I'm gonna have to do is I think I'm gonna have to set up. So we've got a render texture, like we've got a depth texture. Um, and I think what I might do is, like, I need to understand how the texture gets created. So I believe it's based on the render pass, like the existing render pass, which means that I need all the geometry and all the bits in the scene to render, um, to build the depth buffer properly. So I need to render both at the same time. I can't render one or the other. And so I think what I'll need to do is, so I've got my existing render method here. Um, um, I might need another pipeline. Not sure. I need to have a think about how I do this. I will probably need another shader because I'll need to do something different in the fragment shader. Like, I'll need to read the texture. I need to read the texture that's coming. Like, I'll need to have access to the depth texture. I'll need to read all of it, and I'll need to render that write that appropriately. And I'll need to do some sort of scaling because it's currently normalized from 0 to 1, isn't it? So I'll need to multiply it by, like, if I do RGB, I'll need to work out how to grayscale that. I guess, is grayscale, like, does grayscale work? So to do grayscale with RGBA or just RGB, do you make all the channels the same value? I guess you do. All right. So you'd need, instead of, so you'd have RGB the same, but you need to scale that to 255, 0 to 255. As an example. But anyway, so you'd need a separate fragment shader. Oh, sorry, I'm not showing you what's going on here. So you need a separate fragment shader here, at least. So you might as well create a brand new shader called grayscale or something, shader. And it'd largely be the same. This is where I need to know more about how the texture gets built. So I need to understand the pipeline. So if the texture gets built without needing to render anything, then I can just reuse this shader, or I can just modify it, or just copy it and use a brand different shader altogether, and have a toggle in here which says, are we doing the depth texture render, or are we doing the normal render? And then just use a different shader. But it all depends on how that pipeline works and how the texture gets created, which I still don't quite understand. Yeah. Anyway, so I've got some more learning to do here. So I'll do a bit more reading before I try and live stream this. And then the next live stream will probably be just doing this challenge. Then for the model load, I'll do that probably not next stream, but the stream after. And I think they load a cube model. I've downloaded my own model, which is kind of like a fancy looking model. So maybe that won't work. I guess we'll find out. Yeah, where did they do cube? I don't know if they even provide cube. So I guess we'll just need to find it. It'll be a very simple model, obviously. But if we can render a more interesting one, maybe we start with cube and then we try a more interesting one. Yeah. So anyway, folks, that's the idea. So we're going to try that. I'll take a break for now, and then I'll come back and do another stream. I won't wait a week. I'll probably do it through the week sometime once I've had a bit more time to get my head around what that looks like for the depth texture. And I don't know. Hopefully you enjoy the stream and follow me along on the next one. Check out the GitHub repo, and thanks heaps. See you soon.